I'm Anil Kumar, sharing with you some good questions on factoring. We have seen these questions in test paper where students have made some mistake or the other. So I want you to understand how to solve or factorize such expressions. The first one here is 6a times b minus 1 plus 3 times 3 minus b, 3b. b is 10x squared minus 43x plus 28. C is 4x to the power of 4 minus 24x squared minus 108, and D is 20a squared minus 5. You can always pause the video, answer the questions, and then look into my suggestions. Let's begin with the first one, which is 6a b minus 1. So the factor here is b minus 1. The other two could be combined, right? And if I take 3 as a common factor, what do I get? Let us see. So we get 6a, we are given b minus 1. If I take 3 as a common factor, I get 1 minus b. So I don't really get b minus 1. And that is why sometimes students may get confused. What should we do about this one? Now, what we can do is, let's keep 6a b minus 1 as the first factor. In the second one, we could take minus common. So if I take minus common, then I could write this as b minus 1. And that is the strategy. If you open, you get minus 3b and plus 3, right? That's what it is. Now, it is kind of obvious that we can take b minus 1 as a common factor. We get 6a minus 3. Now still, we can factor this expression, correct? When we say factor, we really means fully factored. 3 can be taken out, right? So don't stop here. You have to take 3 as a common factor. It's better to write 3 in the beginning, right? So if I take 3 common, I'm left with 2a minus 1. So that is the fully factored form of the given expression. So if you don't write the last statement, you may lose 0.5 marks, correct? So that's the whole idea of taking this example. Now the other one here is 10x squared minus 43x plus 28. Difficulty faced here is to find the factors. We're looking for product and sum. We want product of 28 times 10 and sum of minus 43. So you're working with a number like 280 and trying to find its factors and then add them to minus 43. That is a difficult thing. My suggestion is factor them individually, right? So we get 28 as, for example, 4 times 7 is 28, and 10 is like 5 times 2, right? So once you know that, you know multiplying these numbers will always result in 480. Question is to find combination so that we could get 43. Now from here, you can see a combination, correct? 7 times 5 is 35. And then we are left with 4 and 8. 4 times 2, which is 8, right? So we could split 43 as 35 minus 8. So that factoring which I did helps to figure out what two numbers could be used. So now we'll begin with this. Let me use another ink here. So we'll split 43x with combination of 75, 7 times 5, which is 35, and 8. So I can write this as 10x squared, both negative, they multiply to positive, 35x minus 8x. Do you see that? So that is why I've taken up this particular equation. Now we can combine the first two. 5 is common along with x. So we get 2x minus 7. And here, what is common? 4 is common, right? So 4, we get 2x, you have to get the same thing, minus 7, right? 4 times 2 is 8. Now we can take 2x minus 7 as a common factor. 2x minus 7, and you get 5x minus 4, right? So the answer here is 2x, let me rewrite this clearly, 5x minus 4, correct? So that is how you have to factor such quadratic expressions. So So I hope you appreciate the idea of factoring the individuals and then figuring out the right choice. Okay, so try this one. Here we have x to the power of 4, x squared and things like that. In such questions, we can make it quadratic by a simple substitution. Let x square equals to t, and then x to the power of 4 will be t squared. So if I do this substitution, I really get this equation as, rather expression as 4t squared minus 24t minus 108. So it becomes a quadratic expression, correct? And now we can apply the techniques learned to factor this one, correct? So one of the common factors here is 4 itself. So we could actually factor this first 4, and we are left with t squared minus 6 times 4 is 24, so minus 6t. When you divide 108 by 4, 4 times 2 is 8, 28 is 7, so we get 27, right? Okay, now we're looking for a product of minus 27, sum of minus 6, 9 times 3, correct? So we could write this as 4 times t negative 9 times plus 3, correct? That gives you that number. And of course, when you write your answer, you have to convert t to x square, right? So we get 4 x square minus 9 times x square plus 3. Now, as soon as you convert this, what do you observe? X square minus 9 can be further factored, right? So let me continue this one. Let me write it here now. So we get 4 x square minus 9 could be written as x plus 3 times x minus 3, and we already have x square plus 3. Is it okay? So that is how you should be factoring. Only at this stage it will be treated as completely factored, correct? D. So I'll begin by using this space here. Here 5 can be taken out, so that's a critical step. Once I take 5 out, I get 4a square minus 1, and now it's easy, right? You could factor this as 5 times 4a square is 2a whole square. So we could write this as 2a plus 1 times 2a minus 1, right? So I hope you learn how these 4 examples can help you, 1, review what you've learned so far, 2, also expose you to problems which some students might face. I'm Anil Kumar, and I hope it helps you. Free feel to suggest, write your questions, and share my videos. Thank you, and all the best.